Welcome back to The Explainer. Today, we're going to take that static roof over your head and transform it into a dynamic, interconnected system. I mean, most of us just look up and see shingles keeping the rain out, right? But today, we're going to build this incredible architectural machine together, literally from the inside out. Let's get into it.
So here's our blueprint for today. We'll start with framing, looking at rafters versus trusses. Then we'll map out the anatomy of the roof, dive into ventilation and leak prevention, navigate those tricky re-roofing codes, and wrap up with proper installation and fastening. Kicking things off with Section 1, Framing, where we'll pit rafters against trusses. Now, every great system needs a solid skeleton. Rafters are actually built and cut right there on the job site. They're what give you those gorgeous custom vaulted ceilings. But, they definitely cost more in labor and are really only best for maximum spans up to 30 feet. Trusses, on the flip side, are your prefabricated powerhouses. They're engineered off-site, which makes them way faster and often cheaper to install. Plus, that triangular web design, it's specifically built to handle much longer spans and heavier loads. Moving right along to Section 2, the anatomy of the roof. All right, let's start with the absolute largest component, the plane. This is the main workhorse of your entire roof. It's that broad, sloped surface where your shingles are doing all the heavy lifting to constantly shed rainwater away from your living space. Traveling all the way up to the very peak, we hit the ridge. This is simply the horizontal line where two of those sloped planes finally meet. But what's super fascinating here is that the ridge actually often houses a specialized vent. This vent acts like an exhaust, allowing all that hot, humid air to continuously escape from your attic. It basically lets the whole house breathe. But hey, not all angles push outward. Valleys are those inner channels where two slopes come together to funnel water downward. And because they collect and move just massive amounts of water during a storm, the National Roofing Contractors Association points out that they are one of the top 3 most common sources of roof leaks. They absolutely require precision to seal correctly, for sure. And then we have the boot. It might look like a minor, almost forgettable little detail. It's really just a rubber or metal cover sealing the plumbing pipes that poke up through the roof. But listen, if this boot is cracked or deteriorating from baking in the sun, water basically has a direct VIP ticket right into your attic. Not what you want. Which brings us to Section 3, Ventilation and Leak Prevention. Get this. According to the U.S. Department of Energy, trapped heat from poor attic ventilation can actually slash your roof's lifespan by up to 20%. Just think about that for a second. Without fresh air flowing in from the soffits and out through the ridge, you're essentially baking your own shingles right from the underside. And here is a totally staggering statistic. Up to 90% of all roof leaks trace back to a failure in just one specific component. Any guesses? It's the flashing. So, flashing consists of these metal strips that act as a vital, watertight shield. They protect the absolute most vulnerable joints and corners, like where your roof intersects with a vertical wall, a chimney, or maybe a skylight. If that flashing is damaged or poorly installed, the entire water-shedding system completely breaks down at that exact seam. Let's transition into the rulebook with Section 4, Navigating Re-Roofing Codes. One major code requirement you simply cannot ignore is the drip edge. This specialized metal strip absolutely has to be installed at the eaves. Its entire job is to guide water safely away from the fascia board and right into the gutters. Without it, water just curls back and rots out the wooden decking underneath, which is a total nightmare. When it comes to building codes, precision is quite literally everything. For instance, there's a strict maximum quarter-inch gap rule for sheathing just to allow for natural wood expansion. And pitch matters heavily too. You actually can't install asphalt shingles on a roof pitch lower than a 212 angle. And if your pitch sits between 212 and 412, well, the code demands 2 full layers of underlayment to prevent water from backing up under those shingles. It's a highly regulated system. Finally, Section 5, Proper installation and fastening. The Galvin rule of roofing installation ultimately comes down to the fastening. Nails must be driven perfectly straight and be absolutely flush with the shingle surface. It's that simple, but so often messed up. If a nail is overdriven, it cuts right into the shingle mat. If it's underdriven or crooked, it leaves the shingle totally vulnerable to catching the wind and tearing right off the deck. So after learning just how incredibly complex this whole system really is, the inevitable question becomes, when do you actually step back, put the ladder away, and call a professional? Well, if you spot any of these warning signs, we're talking missing or curled shingles, a heavy collection of those little shingle granules sitting in your gutters, or, heaven forbid, unexpected water stains and dampness in your attic, do not ignore it. Seriously. More importantly, trying to DIY a repair on a steep slope is highly dangerous and, honestly, it's often ineffective. Just let a licensed inspector or a roofing contractor give you the full, safe picture.
I'm going to leave you looking up at your own ceiling tonight with this final thought. Based on the intricate, interconnected system we just built together today, is your roof hiding a costly secret that you need to uncover before the next big storm hits? Thanks so much for joining me on this explainer, and stay curious.